this 1 as 1 by 1 and I can write 2 as 2 by 1. Okay, now if I have to find the equivalent fraction of this 1 by 1, what I can write it as, uh, suppose if I take numbers 10, if I multiply this 10 by 10, if I multiply numerator and denominator with 10, it becomes 10 by 10. 10 by 10 is 1, right? And same way, if I do it here, now suppose this becomes, if I multiply this also with 10, so this becomes 20 by 10. Okay, why I have taken 10? Because I want 5 rational numbers with me. I could have taken any number. It could have been 1 by 4. So it could have been 4 by 4 and this could have been, this is 8
Ma'am,
by 4.
actually, there is a formula n plus 1.
What happened?
Ma'am, actually, there is one formula.
What is the formula?
Ma'am, the number means there is rational numbers between 1 by 1 and 2 now. We have to take a 5 plus 1, which is n plus 1, and take it as denominator 6.
That is the mean formula. Okay, that is
Yeah.
another way. There are two methods of doing this. That is the another way. One method is the equivalent fraction way, other one is the mean way. So in that mean way, you add these two numbers, you will add 1 and 2, divide by 2. So you get your middle number as, 3 by 2, which is equal to 1.5. So similarly, between 1 and 1.5, you will find another number. Between 1.5 and 2, you'll find another middle number. So that's one way of doing that. Okay? Yes, beta? So this is the
Okay, ma'am.
equivalent fraction way. Yes, beta. So I could take these numbers also, but I thought that these numbers are small numbers where I will not get 5 rational numbers in between. I could get 5 by 4, 6 by 4, 7 by 4. That's it. I could get only 3 rational numbers. So I just multiplied with 10. So that I thought I would get 5 numbers in this. So between 10 by 10 and 20 by 10, 10 by 10 is 1, 20 by 10 is 2. So I can get 11 by 10, I can get 12 by 10, I can get 13 by 10, I have 14 by 10, 15 by 10, and so on. Till 19 by 10, I can have these many rational numbers. So out of which I just have to take the 5. 1, 2, 3, 4, 5. Right? Understood this? Okay. Now suppose if we want to find 5 rational numbers, 5 rational numbers between 3 and 4. Find rational numbers between 3 and 4. Now how will you do that? Let's do with the, as Harshit is saying. So there is another way of doing that. Okay, that is, if I have to find the center point of this, the middle number between 3 and 4. So I will take the mean of 3 and 4 and divide by 2. Okay, so I get the middle number. That becomes 7 by 2 and 7 by 2 will be 3.5. So
Ma'am,
that means
actually, I did not do this one.
you have done this way.
Ma'am, there is another formula, ma'am.
Okay, what is that?
Ma'am, the number of rational numbers between two numbers is 5 now. We have to take n plus 1, which is 5 plus 1, and we have to take the denominator 6.
Okay, just write it in the chat box, which your voice is not so clear. Please write in the chat box. Okay, one method is this way. So you take the midpoint of this, then between 3 and 3.5, you again take the midpoint of this. Okay, that's how you keep getting several numbers, right? Okay, this is one way, but it's better if you do with the other way. See, 3 can also be written in the form as you can say 21 by, if I have to write this like this, 21 by 7. Okay, right? 4 can be written as 28 by 7. All right. Are you understanding this? Yes, Pranav? Okay. Now see, if I have to write this 3, I could write 3 like this also. 30 by 10 also I can write it. I can write 4 as 40 by 10 also I can write. Yes. Are you understanding? So there are different ways of writing equivalent fractions. Okay. So between 30 by 10 and 40 by 10, you have so many numbers. So you can write here 31 by 10, 32 by 10, and 33 by 10. Okay. And so on till 39 by 10. So just pick any five out of these. Right. Similarly, if you have this fraction 21 by 7 and 28 by 7, you can have so many here in between. You can have 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7. You can have here also. Okay, children? Yes. Are you understanding this? Harshit,
Yes.
Pranav,
Yes, ma'am.
okay, beta. And who's this? Rayan, are you understanding, beta?
Yes.
Okay, Jitendra, Sampath,
Yes, ma'am.
Sampath, Akshara.
Yes, ma'am.
Okay, beta. Okay, now let's see, come to the irrational number part. How to locate irrational number on the number line. Okay, so that's irrational number on number line. As we were locating root over 2 on the number line, root over 3, root over 5, we have been doing all this, no? So let's do root over 2 on the number line. How do we do that? We take a number line like this. From 0 to, we take 1 unit this side. Okay, let's take 1 centimeter. We take 1 unit this side. So I take from O to A as 1 unit, right? And then I make a perpendicular here. How do you make a perpendicular? With your compass here, like this. How do you make a perpendicular at a point? You take a semicircle like this. You keep your compass here at this point. This point. You make an arc. You keep compass with the same opening like this. Make an arc and you join it. Like this, you get a perpendicular. This you have studied in your junior class, maybe 6 or 7. Yes. So at A point, you have to make a perpendicular, right? And take that perpendicular to 1 unit distance. So if this is 1, take this also to be as 1 unit. Or you can take it 1 centimeter. Now this point is named as B. Now you join O with B, okay? And keep your compass at point O and measure the distance O to B, okay? And then just make an arc like this, okay, a big arc. So what do you actually get here? So you get by Pythagoras property, by Pythagoras rule, you see that when you have made a perpendicular here, this was like this. O hypotenuse square is equal to base square plus perpendicular square. Is it like this? So that means OA was taken as 1 unit, AB was taken as 1 unit. So this was 1 plus 1 was 2. So OB is, this side it is square. So I have to remove this square, means I will take the root over on the other side. So that becomes OB is now root over 2. And from keeping your pointer at point O and with the radius OB, you just make an arc which cuts this horizontal axis. This is the horizontal axis. Okay. At point, whichever point it cuts. So that point from 0 to O, it's not 0, from O to C. This point is your distance root over 2. Okay. Yes, children. This point from O to
Okay.
C will be your root over 2 distance. Okay, Harshit, if this is also correct. Okay, if your ma'am has taught you like this by taking one number extra, if that is clear, you can follow that way. Okay, if that's clear to you.
Okay, ma'am.
Okay. That's nothing but actually the same thing. What we are doing here with the equivalent fraction, no? That's actually your ma'am has just told you to take, tell which number to take as a denominator. Okay, if you are saying the numbers is 5, so take n plus 1 denominator. Okay, okay, so that's correct. It's okay. So you should always, prefer to take numbers like this 100, 10, 100, like this in your denominator part. So that gives you all the rational numbers. Okay.
Okay, ma'am.
Suppose if I want to find rational number between 3 and 4, and I just multiply with 10 as I did here. So I multiplied with 10, I got 30 by 10 and 40 by 10. So if I had to do this with 100, multiply this with 100. So I would get 300 by 100 and 400 by 100. Okay. So that's a wider thing. So you get all rational numbers between these, right?
Yes,
Okay.
ma'am.
Huh. So that is one way your ma'am has told you. So to find, if you want to find 5 rational numbers, then you take the denominator, multiply the numbers with 6. Okay.
Okay, ma'am.
Okay. Let's see now root over 3. Can we do with root over 3 now? Okay, look children. Now see, we have done this on root over 2. Now if we again make a perpendicular on this line, on root over 2, again make a perpendicular on this line and take it as 1 unit, same as we had taken here. We take it as 1 unit here, that means 1 centimeter. And now you have your point here for 1 unit. Let's take this point as point D. So you join this O with D like this. Now, okay, now this is your right angle triangle now, OBD. Triangle OBD is your right angle triangle now. So here we can say OD is the hypotenuse. By Pythagoras property, we can say OD is equal to OB square plus BD square, right? So OB square will be root over 2 square plus BD will be 1 square, right? So root over 2 square will be 2 itself and this will be 1. So this becomes 3. So OD will be root over 3. So that means you get this distance as root over 3. All right. Are you understanding, children? Hello.
Yes, ma'am.
Okay, beta. Now again, if you have to make root over 4 like this, so what do? Again, you take 1 unit line here. Okay, again you take a perpendicular distance here from this, take this next point as E. Okay, so to take this root over 3 on the number line is that with your compass pointer at O and taking the radius OD, just make an arc like this which cuts this horizontal line at this point, this point, see F. So that distance will be now root over 3. Okay, from here to here will be root over 3 now. Okay. Similarly, to find this root over 4, we all know it's 2 only. So again, with the Pythagoras property, take a perpendicular distance here. Now you have another right angle here. Okay. So from O to E is another right angle. So OE square will be OD square plus OD square plus ED square. Okay. 1 second. This will be now OD square plus ED square. So OD is root over 3 square plus 1 square. So this is 3 plus 1, that is root over 4. So OE is root over 4 and we all know that root over 4 is actually number 2. Okay, so this is actually 2. So this is how, if you keep on making like this, now you get this square root spiral. Okay, if you keep on making like this, then you will get correspondingly, you will get for root over 5 here. So you will keep on getting square root spiral. We call this as square root spiral. Square root spiral. Your, in your school, maybe you must have done this activity also, square root spiral. Okay. Oh, what happened? Okay. And suppose if you want to make root over 5 separately, okay, root over 5. Now on the number line, just take 2 units like this. As we had taken 1 unit, no? Now you can take this as 2 units, say 2 centimeters. From O to A, you take it as 2 units, okay? And take 1 unit here, 1 centimeter here. Join this point, make this as a perpendicular. This point is B. You join O with B, right? So now by Pythagoras property, please always write this Pythagoras property. You have O to B, OB square, that is OB is now the hypotenuse. You can see that OAB is a right angle triangle now. OB square will be OA square plus AB square. Right? So OA will be 2 square plus AB is 1. So that's 1 square. So this becomes 4 plus 1. Okay, so that is 5. So now OB is root over 5. Right? So this is how you get root over 5. If you want to make it separately like this. Are you getting? So now with your center at O and the radius measured OB, just make an arc that cuts the x-axis here, the horizontal axis at a point. So this point from 0 to this point, that is, we name it as A, B, and now C. This distance is now root over 5. You get it? Yes, children?
Yeah.
Okay.
Yes, ma'am.
So like this, you can make it for root over 7, root over 11, root over 13. You can make so many. Okay. Okay. The next thing is that, okay, representing the decimal in the P by Q form. Let's do that also. Now, suppose if I have taken a number to express 1.27 bar, okay, in,
Are you giving these questions from NCERT?
yes, this is from NCERT in the form. You want it from some other book? We are
No,
just
ma'am.
revising the concept. Okay, we are just revising the concept. We'll take from other books also. So express 1.27 bar in the form P by Q. Okay, where you know that P and Q are integers and where Q is not equal to 0. Okay, so what do you do in that case? So let x equals to 1.27. So this is x equals to 1.27. Now we see that here the decimal point is after the 2 places. Okay, these two numbers are repeating again and again. So we have a decimal point here. So what do we do in that case? Suppose if we multiply this with 10, then what happens? My decimal point will shift 1 place towards this side. But that is just 1 place. Okay, so what will I do? I'll multiply this with 100. So if I multiply with 100, my left hand side will become 100x and my right hand side will be, the decimal point will be shifted 2 places now. So this becomes 127 point, but since 2727 is repeating, no? So it will be like this. Decimal point will be here like this. Okay? Yes, children? Okay, so let's take this as equation number 1. We call it equation 2. Now when we subtract this, subtracting equation 1 from 2, so what do we get? 100x minus x gives me 127.27 minus 1.27. Okay. Now after the decimal place number will be 0 here. If you see like this 127.27 and you have 1.27. So whatever you have after the decimal, this is all becoming 0, right? And before the decimal you have 1 minus. So this becomes 126. So this is 126 here. And this is 100 minus 1 will be 99x. So that means your value for x is 126 by 99. So this is in now in a P by Q form. Okay. Yes, children. And you can further reduce it to a lower form. Reduce this fraction to a lower form if it is possible. Okay.
41 by 32.
Okay. What do you get?
41 by 33.
41 by
42 by 33, ma'am.
42 by 33.
Yeah.
Okay. All right. So this is the lowest form of this. Let's try from some other book. Okay. Let's do these sums. Okay. Let's take the number now. I'm taking. Let's do this.
Ma'am, actually it's 14 by 11.
Okay. Okay, beta, whatever you get, just take it, reduce wherever you get the lowest form, no? Okay. You can take that. Okay, now let's take another question. 1 point, express 1.3. Now, here this 2 has a bar. 3 is without the bar. There is a bar over 2 in the form P by Q. Okay, you also do this, please. So express this number 1.32 bar over. Express it in the form P by Q, where P and Q are integers. Q is not equal to 0. Right? So see, I'm just assuming, let's take x as 1.32 and bar over here. Okay, now if I multiply this with 10 first, okay, I'll do it with 10 first because the bar is only over 2. So if I multiply with this with 10, my decimal point shifts to one place, right? And then I want to shift this again to one more place. So that means I'll again multiply this with 10. So this becomes 100x and my decimal point will be shifted to one more place towards the right side. Okay, now it's like this. So what I have to do now, I see here this after the decimal places are now same here in this and here. So I name this as equation number 1. I name it as equation number 2. Okay. How did I choose that? I just saw that after the decimal places are both same. So when I will subtract this, the decimal place will become all 0. Okay. So now subtracting equation 1 from 2, subtracting equation 1 from 2, right? So this becomes 100x minus 10x is equal to 132.2 minus 13.2. Okay, so this is actually bar over. So when I subtract this, the decimal place will be 0 now. So I just have 132 minus 13 because this will become 0 now. This will become 0. So what do I have here? This is 9 and I have 19 here. So this becomes 119 and this is 99x, 90x, okay? Right? 100 minus 10. So here my x will be 119 by 90. Okay? Now if we can reduce it to any lower form, you can try, otherwise leave it like this. Okay? This is your answer. So that means now you have reduced this decimal form to the fraction form, this. Okay. Yes, children? Hello? I hope you are understanding this.
Yes,
Yeah,
ma'am.
ma'am.
Okay, now if I tell you, find the value of 1, this is another question. Find the value of 1.27 bar plus, what was the next question? 1.32. 1.32 bar. Now, if I tell you, if you get a question like this in your exam, 1.27 like this bar, what is the answer of this? So how will you do this? You will first find the fraction form of this. You will find the fraction form of this, P by Q form of this, and then you will add them. So here in this case, I had got my value to be, this was again divisible by 3. So this was coming to be 9. So this is 1, 3, 4 is 12. Okay. 14 by 12, 11. So this was 14 by 11 plus this is what I got here, 119 by 19. Are you getting? Did you understand this? So whatever
Yes, ma'am.
fraction form we have got for this, we will just add them. So take the LCM and add as usual. You do. Okay? Right, children? So this becomes the denominator becomes like this. Okay, and just multiply this. Take the LCM. 14 into 9 will be 9 4 is 36. This is 1260 plus 119 into 11. Just multiply and get your answer here. Okay, just write it here and add them. Get your answer. Okay. So when you multiply this with 9, this is 1 1 9 1 1 9. This becomes 10. This is 3 1309. Okay, so 1309 plus 1260. So sometimes you get question like this also. Okay, so add this. What do you get for this? Right? So in that case, you have to find the P by Q form of the numbers first and then add them. Okay, so this is 5. So that this is 2569. 2569 upon 990. So this is how you get it. Yes? Understood this, everyone?
Yes, ma'am.
Great. Okay, children, so please practice. We have class tomorrow also. We'll revise number system. Okay, we'll do more sums on number system tomorrow. Right? Okay, thank you, children. Bye bye.
Bye, ma'am. Thank you, ma'am.
Bye, beta. Bye.